Welcome to Section 8, Circuit Loading and Demand Factors. It is your responsibility to understand and apply all requirements of the Canadian Electrical Code Part 1, including those not addressed in the training. Do you want to know how to take this course?
Hi, I'm Olivia, your subject matter professional for this learning. I will help you to understand and be able to apply the requirements of the section of the Canadian Electrical Code Part 1.
The aim of this training is to provide new knowledge and to support the development of new skills that you can apply immediately to your job. The purpose is why you are taking this learning. To directly support the purpose, this learning has identified objectives. Here is what you will learn as you take this training. This training is divided into topics. These topics build on each other, so a best practice is to review them in the order they are presented. Save or print a copy of the Quick Reference Guide. It is located in Resources. Use this Quick Reference Guide to take notes and as a practical job aid for this code section.
The following terms are in Rule 8002 of the Electrical Code. Basic load is the load of lighting and receptacle circuits based on the outside dimensions of a specific area of a building occupancy. The value of basic load for each particular building occupancy is different and depends on the type of occupancy from Table 14 and on load calculation requirements for residential occupancies. Such loads as outside lighting, specialty lighting, such as stage and show window lighting, electrical space heating, or air conditioning loads are not intended to be part of the basic load. Calculated load is the load calculated in accordance with the applicable requirements. Demonstrated load refers to the historical maximum demand watt information recorded over at least a 24-month period for the same type of facility. It is equated to watts per square meter. The intent is to compare loads used in similar manner based on the type of fuel source for heating and cooling, occupancy, occupancy load, operational requirements, and facilities in the same geographic area and climates. Control of electric vehicle supply equipment loads is the process of connecting, disconnecting, increasing, or reducing electric power to electric vehicle supply equipment loads. Electric Vehicle Energy Management System is a means of controlling electric vehicle supply equipment loads comprised of any of the following: a monitor or monitors, communication equipment, controller or controllers, timer or timers, and other applicable devices. Section 8 is a general section of the code that provides the requirements for determining the ratings for electrical equipment, supplying various types of loads, and determining conductor ampacities for consumer services, feeders, and branch circuits. Branch circuit conductors run from the load side of the last overcurrent device to the point of utilization, which may be a connected load or an outlet, such as a receptacle. Feeder conductors run from the load side of the service disconnect to the supply side of the last overcurrent device. Consumer service conductors run from the point of connection with the supply authority lines to the supply side of the service disconnect. Voltage drop is a very important topic. The primary cause is conductor impedance, which increases as the length of the conductor increases. This can result in lower than satisfactory voltage at the load or equipment, unless suitable preventive measures are taken. Measures may involve using larger conductors to feed the utilization load. The total voltage drop may not exceed 5% from the supply side of the consumer service to the point of utilization, or 3% in feeder and branch circuit conductors. Voltage drop is based on the connected load if it is known, or 80% of the overcurrent protection device when the load is not known. Known demand loads typically include hardwired equipment, whereas 80% of the overcurrent protection is most often employed in circuits that are feeding general-purpose lighting and receptacles. Maximum conductor length based on the allowable voltage drop can be calculated using Table D3 or Table D4. Table D3 is used for low voltage circuits, and Table D4 is used for extra low voltage circuits. Voltage drop is based on the calculated demand load of the feeder or branch circuit when the overcurrent device is determined by other sections of the code. Examples of this include, but are not limited to, motors, transformers, capacitors, welders. The maximum length of a general-use branch circuit in a dwelling unit while maintaining the appropriate voltage drop can be determined using Rule 8-102 and Table 68. It takes advantage of the fact that in most dwelling units, the distance between the supply side of the consumer's service and the branch circuit overcurrent device is often short, with very little voltage drop. As a result, Table 68 permits an increased distance on the branch circuit conductors than would be permitted by a calculation using Table D3. Table 68 lists the maximum distances permitted on a general-use circuit based on the conductor size and overcurrent device. To use Table 68, the circuit must be a general-use 2-wire circuit, use 90 degrees Celsius conductors, not exceed 120 volts, not exceed 20 amperage, not exceed a 30 degrees Celsius ambient. Note, the distances are measured from the supply side of the consumer service to the point of utilization. As listed in Appendix B, excluded circuits include household appliances, for example, refrigerators, washing machines, kitchen receptacles, electric heating and cooking appliances, other specific receptacles installed in dwellings, such as those dedicated for medical devices. The maximum distances for these circuits should be calculated in accordance with 8-102.1 and Table D3. In industrial establishments where maintenance and supervision take place by qualified persons, the design must ensure that the voltage at the point of use is within the rating or voltage tolerance of connected device or devices. Essentially, this permits the voltage drop to exceed the 3% or 5% values when the conditions of Subrule 4 are followed.
Please read the scenario and follow the instructions to submit your answers.
It is important to understand the ampacity of a service, feeder, or branch circuit as it relates to circuit loading. Because some circuits have conductors with ratings higher than the overcurrent protection, as would be the case to meet voltage drop requirements, and other circuits have overcurrent protection with higher ampacity ratings than the conductors, such as is the case in motor circuits due to startup surge, the code requires that the lower of either the conductor ampacity or the overcurrent protection is used to determine the circuit ampacity. When loading up a circuit, the calculated or connected circuit load may not exceed the ampere rating of the circuit. As a default, any calculated load is considered a continuous load unless it can be proven that it will meet the non-continuous requirements outlined in the table as per Subrule 3. The table shows the size of the load, total time on for continuous and non-continuous loads. In the continuous column, it is denoted that loads have a total on time greater than 1 hour in a total 2-hour period for loads up to 225 amperes, and a total on time greater than 3 hours in a total 6-hour period for loads above 225 amperes are considered continuous. In the non-continuous column, it is denoted that loads have a total on time of 1 hour or less in a total 2-hour period for loads up to 225 amperes, and a total on time of 3 hours or less in a total 6-hour period for loads above 225 amperes are considered non-continuous. Where a fused switch or circuit breaker is marked for continuous operation at 100% of the ampere rating of its overcurrent devices, the continuous load as determined from the calculated load must not exceed the continuous operation marking on the fused switch or circuit breaker, and unless it is required by the item, must not exceed 100% of the allowable ampacities of conductors selected in accordance with Section 4, or 85% of the allowable ampacities of single conductors selected in accordance with Section 4. Where a fused switch or circuit breaker is marked for continuous operation at 80% of the ampere rating of its overcurrent devices, the continuous load as determined from the calculated load must not exceed the continuous operation marking on the fused switch or circuit breaker, and unless it is required by the item, must not exceed 80% of the allowable ampacities of conductors selected in accordance with Section 4, or exceed 70% of the allowable ampacities of single conductors selected in accordance with Section 4. Note that fused switches or circuit breakers not marked as suitable for continuous operation 80% or 100% are considered as suitable for continuous operation at 80%. See the note in Appendix B for more detail. The continuous load, as determined from the calculated load connected to a cable bus, must not exceed the values determined using the overcurrent device's continuous rating and wiring method. Here is a short activity to apply what you just learned. Enter your response and select Submit.
The following steps explain how to apply circuit loading factors when determining the rating of the overcurrent device sizing, overcurrent devices, and conductors.
Step 1. Determine if the load is a continuous calculated load or an equipment load continuous calculated. Step 2. Determine the total continuous and non-continuous loads. Continuous loads are 171 amperes. Non-continuous loads is not applicable here. Step 3. Determine that the conductors terminate at either end, or both to a circuit breaker or fusible switch. Step 4. Determine the fusible switch or circuit breaker's continuous operation rating, 80%. Step 5. Determine the wiring method and ampacity table, Tech 90, Table 2. Step 6. Determine the maximum circuit loading permitted using equipment rating and wiring method, 80% as per 8-104-6A. Step 7. Using the circuit loading from Step 6 and the loads from Step 2, determine the minimum circuit breaker and conductor ampacity, minimum ampere rating of the circuit. Continuous load divided by 80% plus the non-continuous load, 171 divided by 0.8 plus 0 equals 213.75 amperage. Step 8. Minimum standard rated circuit breaker is 225 amperage, Table 13. Step 9. Determine the equipment termination temperature rating, 75 degrees Celsius. Step 10. Determine the minimum conductor size using the appropriate temperature column from the table determined in Step 5. Table 2, 75% Celsius column, 4-aught AWG, 230 amperage. Other than services calculated in accordance with Rules 8-200 and 8-202, service and feeder capacities must be increased where the design of an installation is based on requirements that exceed the minimum requirements of Section 8. When multiple loads are connected so that only one can be used at a time, the load providing the greatest demand should be used to determine the calculated load.
When electric space heating and air conditioning loads are installed and interlocked to prevent simultaneous operation, the larger greater of the electric space heating or air conditioning load is used to calculate the load after any demand factors allowed in the code have been applied.
This rule may seem confusing in that it pertains to loads that are cyclic. Although these loads are physically connected so that it is possible to operate them at the same time, the operation of the system is such that this does not usually happen in normal circumstances. In this situation, the ampacity of the feeder conductors can be based on the maximum load that might be connected at any one time. For example, in a machine shop, many machines are connected, but usually only a few operate at one time, depending on the need during that business cycle. In this scenario, any lessening of the load requirements requires careful discussion between the parties involved. In such cases, it is better to calculate loads based on the more conservative load requirements. Otherwise, if the installed electrical infrastructure is not large enough to accommodate future load growth, an expensive change may be required. To reduce the demand factors associated with motor or air conditioning loads supplied by a feeder or service, a demand factor can be determined by a qualified person, provided a deviation has been allowed in accordance with Rule 2-30. The ampacity of conductors of feeders or branch circuits must be in accordance with the sections of the code that deal with the respective equipment being supplied. This rule points out the fact that the application of demand factors to some loads can result in the conductors of a branch circuit being larger than the feeder conductors, or the conductors of a feeder being larger than the service conductors. In such cases, the ampacity of feeder conductors are not required to exceed that of the service conductor's ampacity, and the ampacity of the branch circuit conductors are not required to exceed the ampacity of the feeder conductors supplying such branch circuit. Where additional loads are to be added to an existing service or feeder, these additional loads must be calculated in accordance with this section. However, where it is impracticable to calculate the existing loads, accurate information on the existing already installed loads taken over the last 12 months can be used to verify that the ampere rating of the existing feeder or service is enough to accommodate newly added loads. Except for loads calculated using rules for single dwellings, apartments, and similar buildings, the use of demonstrated loads to determine the minimum feeder and service load calculations is permitted, providing calculations are performed by a qualified person as determined by the regulatory authority having jurisdiction. A demonstrated load can be used where buildings similar to the one in question already exist and can provide the necessary information required to calculate a new service or feeder. For example, a chain of restaurants could have several buildings already in operation. Using the information from the existing buildings, a watt per meter squared value could be calculated and applied towards the sizing of any future services or feeders. Demonstrated load divided by area equals watts per square meter. Example, if an existing restaurant has a demand of 100,000 watts and is 100 meters squared, the feeder or service for the identical new restaurant could be sized using 1,000 watts per square meter, or 100,000 watts per 100 square meters. As per the rule, the calculation must be done by a qualified person as determined by the authority having jurisdiction. The Electric Vehicle Energy Management System determines the allowable demand load for electric vehicle supply equipment. The demand load for the equipment must be equal to the maximum load allowed by the system. The demand load for electric vehicle supply equipment is not required to be considered in determination of the calculated load if the Electrical Vehicle Energy Management System monitors the load on a consumer's service and feeders and controls the load of the electric vehicle supply equipment in accordance with Rule 8-500. With this system, the electric vehicle supply equipment load is not required to be added to the calculation. Determination of areas. Living areas designated in Rules 8-200 and 8-202 are determined from inside dimensions. It includes the sum of 100% of the area on the ground floor, 100% of any areas above the ground floor used for living purposes, and 75% of the area below the ground floor. It is very important to understand the different calculated loads for services and feeders regarding different types of dwellings. This is particularly true in single dwellings, in which the calculated load for the service or feeder is based on the size of living area. The minimum calculated load for a service of feeder is 24,000 watts when the floor area, exclusive of the basement, is more than 80 square meters, and 14,400 watts when the floor area, exclusive of the basement, is less than 80 square meters. Demand factors also differ when other types of housing or structures are involved. Although each individual dwelling unit in an apartment or similar building may be treated similar to a single dwelling, the difference in operational needs of a group of dwellings supplied from a single feeder or service allows demand factors to be applied. Rule 8-202 focuses on the calculated loads for services feeders as it applies to apartment buildings and similar buildings. Subrule 1 specifies the loads and demand factors in dwelling units that can be applied when calculating the minimum service or feeder conductor ampacity supplying a dwelling unit in an apartment building. The basic principles that apply to a single dwelling are covered in Item A, except that there is an extra step when calculating the basic load for small one-room apartment suites. Subrule 2 allows the loads in dwelling units that are calculated in accordance with Subrule 1 not to be considered continuous, making the requirements of Rule 8-104, Subrule 5 or 6 not applicable. The criteria for the determination of the ampere rating of the feeder supplying loads in a dwelling unit of an apartment building in accordance with Rule 8-202 must be based on Rule 8-104, Subrule 2 only. Subrule 3 specifies how to calculate the minimum ampacity of a service or feeder supplying a minimum of 2 dwelling unit loads from a main service. When loads not located within dwelling units, for example, house loads, are added to the calculation for a service or feeder size, the total loads within dwelling units are not considered to be continuous loads. However, the total loads outside the dwelling units, for example, house loads, must be considered as continuous loads for the purpose of Rule 8-104, Subrule 5 or 6. Demand factors applied to such house loads must be used as required by Rule 8-202, Subrule 3E. Subrule 4 is applicable when the feeder conductors feed only loads located outside the dwelling units, such as a hallway and outside lighting loads, laundry room loads, mechanical room loads, and elevator loads. It requires that, after any demand factors allowed by the code are applied, feeders supplying these loads outside dwelling units or house loads not be less than the rating of the equipment installed. These loads outside the dwelling units are always considered to be continuous, unless it can be shown through their off or on times that they are non-continuous.
Please read the scenario and follow the instructions to submit your answers. How well did you do?
Rule 8-204 provides the requirements for determining the calculated load for a service or feeder conductor that supplies a school. In Subrule 1, the method determining the calculated load for a service or feeder conductor for a school is described. Subrule 2 lists the demand factors that are to be applied to those loads calculated by Subrule 1. Rule 8-206 provides requirements for determining the calculated load for a service or feeder conductor supplying hospitals. Subrule 1 specifies the method of determining the calculated load for a service or feeder conductor for a hospital, while Subrule 2 lists the demand factors that are to be applied to the loads calculated in Subrule 1. Hotels, motels, dormitories, and buildings of similar occupancy are provided for in Rule 8-208(1). This rule provides requirements for determining the calculated load for a service or feeder conductor supplying a hotel, motel, dormitory, or building of similar occupancy. Subrule 1 specifies the method to determine the calculated load for a service or feeder conductor for this type of occupancy. Subrule 2 lists the demand factors that are to be applied to the loads calculated in Subrule 1. The basic requirements for determining the calculated load for service or feeder conductors supplying building occupancies other than those covered in Rules 8-200 to 8-208 is provided in Rule 8-210. This rule establishes a method for calculating loads in order to select the minimum service or feeder conductors supplying other types of building occupancies. To establish basic loads, code users must refer to Table 14, which extends the concept of watts per square meter and the application of various percentage demand factors in calculating loads for services and feeders in different types of building occupancies. Loads such as electric space heating, air conditioning, power, and special lighting are handled separately as special loads, using their rated loads and applying the demand factors that are allowed by other sections of the code. For example, Section 62 concerns electric space heating and Section 28 motor loads. Calculating the load for feeders is not just limited to the overall building needs. Specific equipment within the building is also addressed. Rule 8-212 covers specific types of lighting, such as exit signs, emergency lighting, and show window loads. This type of lighting is not confined to one location within a building, thereby making the method of calculating load for feeders per specific area not always practical. In Subrule 1, an alternative method is established using the connected load of circuits instead of watts per square meter for calculating the loads that are supplied by the panel and determining minimum size of feeder. Subrule 2 explains the requirements for calculating the demand for show window lighting installations. The length of the window is measured along the base, and a value of 650 watts per meter is applied to establish a demand. This subrule also allows lower demand to be used where special permission has been given in accordance with Rule 2-030 on deviation or postponement. In colder climates, outdoor parking lots are generally equipped with receptacles at each parking stall. These receptacles supply car engine block heaters, battery warmers. In colder climates, outdoor parking lots are generally equipped with receptacles at each parking stall. These receptacles supply car engine block heaters, battery warmers, and sometimes in-car heaters to keep windows clear of frost and make the interior of the car more comfortable until the engine warms up. The demand set by receptacles varies per use. While learning about Rule 8-400, it is important to remember the following two definitions: controlled and restricted. Controlled is the power to the receptacle is cycled by other than a manual operation. Some receptacles are controlled by an automatic system that responds to the temperature and cycles the power to the receptacles. Another type of system, called controlled loading, supplies receptacles for 30 minutes every hour, provided the temperature is below a preset value. If the temperature rises, no power goes to the receptacle. Restricted, which pertains to power to the block heater only, and where the use of an in-vehicle heater or other vehicle heating devices are not permitted. Some premises post notices prohibiting the use of in-car heaters because a restricted loading system is in effect. In this system, one 2-wire circuit supplies both halves of a duplex receptacle, so that use of an in-car heater can trip the overcurrent devices when another vehicle is sharing the receptacle. Rule 8-400 also provides the requirements for branch circuits and feeders supplying heater receptacles in parking lots. This rule does not apply, however, to 1 or 2 outdoor or garage receptacles associated with a single dwelling because they are covered by the basic demand for the single dwelling. At least one branch circuit protected by an overcurrent device rated or set at not more than 20 amperes shall be provided for each duplex receptacle or for every 2 single receptacles referred to in Rule 26-700-2. This circuit can supply a single duplex receptacle or 2 single receptacles. Normally, one duplex receptacle is set in the middle of the 2 stalls. Subrules 3 and 4 cover the demand requirements for spaces that are controlled or restricted and spaces that are not controlled or restricted. Where the loading in each parking space or stall is not restricted or controlled, a separate branch circuit shall be provided for each parking space or stall, and the feeder or service conductors shall be considered as having a demand load as follows. The table also shows demand loads that are restricted or controlled when branch circuits are provided for parking spaces or stalls. Comparison of systems in parking lots. With the growing popularity of electric vehicle energy management systems have been developed. These systems have the capability to monitor electrical loads, which allows them to control the electric vehicle supply equipment load based on changing demands in the building and the system requirements. Rule 8-500-1 states that the electric vehicle energy management systems are permitted to monitor electrical loads and control electric vehicle supply equipment loads. An electric vehicle energy management system must not permit the load of a branch circuit, feeder, or service to go beyond the requirements of 8-104, 5, and 6, according to Subrule 2. In Subrule 3, an electric vehicle energy management system is permitted to control electrical power using a remote means.
You covered a lot in this course. This summary helps you to recall the main concepts and requirements of this code section. You have now completed the learning on the main concepts and requirements of this code section. Next, you will take the open book quiz through the link on the course page. Click Close to exit, and then start the quiz.